This week's episode of the Cloudcast is brought to you by Intel Cloud for All, driving the creation of thousands of clouds.
Cloudcast Media presents from the massive studios in Raleigh, North Carolina. This is the Cloudcast with Aaron Delp and Brian Gracely, bringing you the best of cloud computing from around the world.
Good morning, good evening, wherever you are, and welcome back to the Cloudcast, coming to you live from our massive studios here in Raleigh, North Carolina. Aaron, good to have you back from Barcelona. Good to have you back from DockerCon. How are you doing tonight, man?
Good. Yeah, and I figured, you better do the intro tonight because, after however many shows I did, everyone's sick of listening to me now.
I know. I think you cranked out about 9 shows here over the last couple of weeks. You earned your Christmas bonus. A lot of really good shows, a lot of good feedback we've gotten from people, but we're gonna go off of Docker tonight. So hopefully folks are got their fill of Docker stuff. A couple things real quick, just some house cleaning things for everybody. First off, this will probably be, the last show. We always do a year-end wrap-up show, but this will probably be the last show of the year. So hopefully everybody's having a great holiday season. Hope you have a great holiday season. Thank you so much for being great listeners, for telling a friend about the show. It continues to get bigger, continues to have more listeners. So thank you to everybody who listens and gives us a little bit of their time every week. The other thing, I want to thank everybody who's made a contribution, big or small, to the Krispy Kreme Fund for the North Carolina Children's Hospital. I think we're up over $1,000 so far, and we're still just in the beginning of December. So thank you to everybody. Great way to give some money to help kids who are having a hard time, tax write-off. So thank you to everybody for that as well. So,
and Brian, are you running?
I am running.
Oh, okay.
I'm running a little bit.
You're further along than me this year, then.
I am running a little bit. I'm trying to get off my lazy butt, but So hopefully the weather stays good here in North Carolina. It's been nice lately, so knock on wood. But anyways, enough about us and enough thank yous. So let's get to our guests. So tonight, we've talked about a lot of different stuff. We've talked about platforms, we've talked about microservices and stuff, but sometimes we talk about them at a high level. Tonight we've got a very cool guest and a very cool technology. So first and foremost, Larry McQueary, who's product manager for NATS.io, or the NATS Cloud Native Infrastructure. Welcome to the show.
Thank you very much. Thanks for having me. Good to be here.
So first and foremost, let's talk a little bit about your background. So you formerly work for Apcera. We've had Derek Collison on the show before. Brian Flannery is a longtime friend of the show, been around the show, giving us feedback for a long time. Tell us a little about what you do both at Apcera, but also your background, because you've got a ton of background around messaging from your days at Tibco and work you've done with Derek. So give us a little bit of background on yourself, as well as kind of an introduction to NATS as a platform.
Sure, happy to. So yeah, I do have something of a background in messaging. Here at Apcera, I've only been on board about 6 months maybe, but I am, as you've already mentioned, responsible for product management for NATS, as well as, I've kind of got a business development role as well. We're a small company. Everybody does a lot of things, as I'm sure you guys can appreciate. Prior to that, I was at Tibco. My background has been messaging for many years. I was at Tibco about 15 years, and before that did some things that are, I think, relevant to what we'll talk about here a little bit. Satellite command and control and telemetry applications, and just things that involve command and control in general. So that's kind of how I got into messaging, and ultimately, it even comes into play today at Apcera. So I think the question was also sort of what's NATS?
Yeah.
So, Tibco has a number of well-known messaging products, and we're not here to talk about that, but they sort of introduced the concept of a message bus, and certainly helped popularize that term. As we enter the era, and you guys obviously focus on this, as we enter the era of platform of a service a few years back, we find that the traditional message bus is left wanting in some ways when it comes to trying to do things in the cloud. I'm sure that's true of many technologies, of course, but certainly at a fundamental level where you're trying to get applications to communicate with one another efficiently and effectively at scale, you need a good mechanism to do that. And Derek has probably told this story on the show, so I won't bother you with too many apocryphal tales, but in the building of Cloud Foundry a few years back, he found that he needed a a stable, high performance, and yet simple, sort of elegant messaging system to do what he needed to do. He tried some other well-known messaging systems that I'm not going to mention out of respect, but he found that other systems left him in situations where he didn't have a stable environment at scale, and that was problematic. So, having done a lot of work at TIBCO and innovated a lot there, he kind of applied some of the same knowledge to solving the problem of building what we call a control plane for cloud environments. And that's really where NATS came from. Originally implemented in Ruby, it's now been re-implemented in Go as of a couple of years back. And we now have a full community around it. And we're really happy to be involved in podcasts like yours, as well as to be asked to speak at various conferences. And, we've done a number of user meetup groups. So we're enthusiastic. And as you mentioned, Brian has been helping us build the community, build the awareness. And, we're doing our best to extend the reach and make NATS as applicable as possible to as many, applications as we can.
So Larry, help me out with something there. So NATS is part of Apcera's platform, if you will, but it's also an independent project. And so help us a little bit with the compare and contrast of how are they connected, how are they separate?
Sure. So as I mentioned, NATS is, we think of it as a control plane, and that's really its function. So on the one hand, it is embedded within the Apcera platform. So again, I'm sure you've probably talked about the Apcera platform here before with Derek or perhaps others, but effectively it's a secure, policy-driven cloud application platform, and the NATS role within that is really behind the scenes, underneath the covers. Your workloads, your applications, if you're a user of the Apcera platform, don't really directly interact with NATS. You're not using it directly as a messaging bus as an Apcera platform user, but everything that you do and everything that your workloads do is really effectively coordinated and signaled using NATS. So when you think about that message bus metaphor that that we use so often, that's really true in this case. There are many moving parts in the Apcera platform, many workloads. There's a lot of stuff to coordinate, and you need to signal a lot of different things simultaneously and efficiently to make things happen. So that's the role that NATS plays as an embedded part of the platform. Separately from that, again, we/Derek, obviously, as the visionary, saw that this is something that, what NATS does is something that obviously is applicable to direct interaction and or integration with applications. And so spinning it off as an open source project just seemed like a natural thing, because there are so many folks out there who, need something simple and effective for messaging that doesn't require literally hundreds of lines of code to get working, and maybe hundreds of lines of config files. So NATS as a separate project is exactly the same thing that's embedded in the Apcera platform. In other words, Apcera platform just carries NATS as a dependency. We've open sourced the project itself to the community. We've got about 14 different client APIs, of which Apcera maintains 5, and the other 9 are, maintained by the community.
So let me ask sort of a real basic question, because I know the audience has different amounts of background. For large applications, the big sort of what people call monolith applications, there's tons of intercommunication that's going on between tiers of that application. They tend to be sort of sometimes called inter-process communication. Sometimes they are, messaging and so forth. What's new about today's microservices? I mean, obviously, there's lots of pieces now. It's the basics of the microservices piece. But give us what's the evolution of what used to be sort of inter-process communication and the things that went on in the big monolithic applications to what goes on in the microservices applications, and why it's so important to have a high performance messaging bus or control plane.
Great question. It's funny. I always say that, actually, there is a saying in general. I'm probably going to hack and misquote here, but, no matter how much things change, they remain the same. And I think that that's true in this space as well. When we talk about messaging and the evolution of messaging, within an ever-changing sort of enterprise landscape and or web landscape or internet landscape. When you talk about monolith applications, obviously I'm a little, I'm pushing 50, so I definitely remember real monolith applications on mainframes and, the dawn of the client-server era. So there are many parallels, I think, between what you saw 20 years ago and that kind of, 20 plus years ago, good Lord, time flies, with that kind of transition from an environment where you've really just got some jobs talking via some batch-based queue system to other jobs that may not even be running at the same time on mainframes, jobs that are running overnight. You move from that to, we're going to have applications that are long-lived that run on a server and have clients connect directly to that application over some local network to, more recently, and let's say for the last decade plus, 10, 15 years, kind of a SOA integration environment where that distributes even further over the internet. You get web application servers and other things involved, to REST, to whatever. Along the way, there have been various evolutions of the underlying technology, and I guess that's where message-oriented middleware comes in. One of the earliest versions of that was RPC, and that evolved into the concept of, if I can do RPC, that's great. I can do a one-to-one communication or request reply, but what I really need is to put out data to many different applications simultaneously without having to carry the overhead of doing that over and over again. So that problem really has effectively never changed. As we go from that monolith to client server to web tier applications, and so we then come sort of back around to REST, which is a form of RPC, and microservices is just taking all of those what once we would have thought of as client server applications, and we're making super client server applications where anything can be a service and anything can be a client. And there can be, many thousands of these applications living in an environment. So basically, you need a way for those to communicate. And, many folks are trying to use conventional methods like RPC over HTTP, REST, et cetera. And, NATS is kind of our solution to the problem by harnessing technology that's already proven, which is publish, subscribe, one-to-many, one-to-one, message bus type technology.
And, if we think about it, like, I always try and put everyone always goes, give me an example of an application that does those things and so forth. I mean, is a simple example of that, would that be that everybody kind of knows, like if somebody does a Twitter update and they've got, several thousand followers, is it sort of dumping things on a message bus? You could have lots of clients that are listening for any sort of status update from some publisher, if you will. And then they can go off and do whatever work they might do. They might be logging things. They might be collecting stats. They might be publishing it to some set of applications. Is that a simple way to think about this? It's it's sort of a broadcast medium onto lots of listeners that can then do whatever work they're programmed to do.
That's exactly right. And I mean, we often talk about it in terms of sort of a radio. Yeah, broadcast is the right way to look at it. Kind of a radio broadcast or radio signal. It's something that you don't have to worry about, knowing who's out there. For instance, I'm sure that you guys care very much about your subscribership, but you have, a good certainty that when you put some information out there, when you put a show out, a lot of people are gonna download that. You're not sure who, but it's there for them to use. And publish subscribe messaging is kind of exactly like that. It's exactly as you described. It's a virtual circuit that many people can connect to. We typically think about it like dial tone or even the power in your house. It's something you can plug into and use or not, but it's always going to be there when you pick up the handset. Well, handsets, that's such an old term, but I hopefully everybody that's listening gets the idea. You pick up your phone, or you plug something into the power outlet and stuff just works. And that's really kind of, again, the concept here. Another analogy quickly is, a lot of folks at least understand, hopefully, financial trading applications. One of the most common uses and for the folks back in my TIPCO history, that sort of initially conceptualized this, stock trading is a great application, to describe this. You've got stock quotes or price updates that are happening for stocks, and they're constantly changing. The bid and the ask the price that the stock's selling for, or that people are willing to bid to buy it, are constantly changing, and you need to constantly pump that information out to whoever needs it. And that's another very typical application for anybody that's done any kind of either online or closed system trading. Other examples, but again, I think your Twitter feed sort of example kind of hits the nail on the head.
Yeah, and so it really seems like this is a perfect setup into mobile and Internet of Things kind of technologies, without a doubt, because it seems like, especially with the pub-sub kind of philosophy, I mean, the amount of data and the amount of devices is certainly not going away and not getting any less anytime soon. So I guess my question to you is so the back end of them, if you could go into a little bit of like maybe an IoT kind of analogy, right? Is Twitter a good enough analogy, or is there something more specific when it comes to really doing these things at scale?
I think Twitter's a good enough analogy. I'm not as familiar personally with the back end of Twitter, but I can certainly talk in general terms about back ends. I mean, that's really, I think the back end is probably the more important thing to think about. When folks talk about IoT, there's a lot of interest in talking about, sort of the footprint on a device and using things like MQTT and how does that protocol work, et cetera. The back end really is a huge concern, because although you can define a simple protocol, a lightweight protocol for communicating between devices in the back end, the ability of that back end to scale kind of seamlessly and simply to handle demand spikes in particular, that's one of the biggest areas of concern for this type of technology, is not just being able to handle millions of users potentially, but being able to handle the spike that may happen when some large news event occurs, for instance, and a bunch of handheld devices suddenly hit a website or hit their trading application or hit their whatever it is, ESPN sports applications to see a replay of a sporting event. The ability of the back end to handle that kind of dynamic load increases and decreases, its ability to handle just significant steady load in general is really significant. And that's again where something like NATS comes in. It's been engineered specifically to be able to handle high capacities of clients and data seamlessly to be able to do that sort of thing. It's not, I'll tell you firsthand, it's really not a trivial problem to solve. There are lots of messaging solutions that exist, and none of them is really ideal, I think, in the cloud environment specifically for solving those problems. So that's one of the big problems we are trying to solve with NATS.
Yeah, I'm thinking about the types of applications that might work for this, and we use the sort of broadcast analogy. Is there anything, obviously, you've got to have a way to communicate into the message bus, but is there any concept that if I have an application that it has to know about the other things that'll come onto that message bus ahead of time? Is it, I guess the question becomes, how do I have to care about who else is listening or who's publishing? And then, if I don't, how do you sort of protect that the system doesn't get overwhelmed or something like that?
Well, there's a couple different aspects to that. First of all, no, you definitely, one of the principles that I guess we, to use this term in a double way, that we subscribe to, one of the ideas that we subscribe to is that you don't really, in publish-subscribe messaging, location transparency and decoupling of senders and receivers is very, very important. So no, there is no and should be no assumptions really on the part of particularly a sender or publisher about who's out there and listening. Everything is addressed using subjects, and you send data to a subject or publish it to a subject. And NATS, the broker, if you will, the system in the middle, will ensure that messages get where they're supposed to go. So we certainly encourage anybody that designs an application around NATS or really around any messaging system to not make those assumptions. On the receiver or subscriber side, the story is a little bit different. Obviously, you need to know what you're looking for, or how to sort of connect first of all, as well as how to get the data that you're particularly interested in. And so there are various mechanisms, obviously, for advertising that kind of information, various service discovery tricks that you can use to do that, and that's really what users are doing. Heroku, other tools that are out there let you do that. So it's really quite simple. There's not a bunch of metadata you need to know about in NATS. You just know a subject name that you want to subscribe to, and you subscribe, and data begins flowing. So pretty straightforward stuff overall.
Okay. And sometimes we hear from as sometimes we try and break down the cloud platforms, the PaaS platforms. NATS is something that can be separated out, but it can be part of it. Is NATS also doing what people call service discovery? Obviously, people can listen on to stuff. Do they use that for learning about new services, or is that typically a different function? And then you figure out what's out there, and then you attach yourself to the message bus.
I would say that it's one. Service discovery is something that NATS could be used for. Certainly, it would be something you could use as part of a service discovery framework. And it would be a very efficient, mechanism for communicating service discovery type stuff, or for doing, sending out a request and getting back, a list of all the different data providers that might be out there on your NATS network or connected to NATS. But really, we don't see that as a primary focus of NATS. It's just one of many, many, many different applications that could be targeted, for use by NATS. In terms of cloud application platform, I think one of the questions, and you may have hinted at it earlier when we were talking about the differences between NATS and the cloud platform, we do look at those things as being, kind of synergistic. We're not only embedded in our NATS platform, but, right now, or even at Apcera, we're looking at how can we leverage NATS as a messaging framework for users on top of our platform as well. And I think that's where, some interesting applications like service discovery, like, command and control, other things, become very interesting. We've even got some users, I contrasted versus RPC a minute ago. We've even got some users that are using NATS as a transport for gRPC, as an example. So there's really a lot of different ways that NATS can be threaded into and out of various other application types, including service discovery and other things.
Yeah, and Aaron and I have sort of debated this a little bit. We get a chance to talk to a lot of different people. He was obviously at DockerCon. We've been trying to kind of get a feel for the industry as to, are more companies and developers kind of building their own platforms, sort of in a I call it unstructured. People call it a pluggable way, right? So, NATS is a part of what they do, but maybe it's not, part of Apcera. Or are more people kind of saying, hey, like you said, I like the synergistic piece of it. I like it sort of structured together. What do you see in the market? I mean, you guys, you might be a little bit sort of biased because you're part of both of them. But what do you see people kind of use as decision criteria as to, when to use more of a platform that's more inclusive of the technologies, and when do you see them, using elements of it kind of independently or pluggable?
I think a lot of it, there's various things. I worked at an enterprise software company for a long time, and I know the decisions like this are not always trivial. There's political, organizational, and other things that go into it. But I think more than anything, risk is a factor that companies look at, when we look at the commercial user space. And there's less risk, I think, a lot of times in using a platform. So you're right. I do have a vested interest in advocating my own company. But I think in general, folks want to do things that are easy. They want to follow the path of least resistance. And to the extent that you've got a platform that also includes some nice other features that are easy to use, you kind of want to use that. That said, I mean, there's really a broad range of users out there. I often lament the fact that a lot of existing open source messaging is built by engineers for engineers, meaning that it's complex. And, I've been an engineer for a long time myself. There's a tendency to look for really cool solutions that do really cool things, but often they're rather complicated in the way that they get there. And it's easy to fall in love with that technology and with the details. But often the folks that are paying your paycheck are less thrilled with the amount of time you spend learning to use them. And so that just kind of circles back to the whole risk thing. I think that smart engineering departments, smart business stakeholders want to do the things that really make things easy to get projects into production. particularly in the era of continuous integration. You just want to get things running and incrementing slash evolving very quickly so that you can achieve some kind of financial benefit off of that. So. Yeah, I mean, again, I think that larger organizations are going to tend towards those models of what's going to make this easiest and most cost effective. I think that smaller organizations are really all over the place. We talk to a lot of folks who are enthusiastic members of our community that would like to build a lot of things themselves. And so on the one end, Apcera's platform, helps businesses. On the other end, I think NATS has a broader appeal from, to both sides of that spectrum, really.
And I think that aligns to what we hear quite a bit. We hear the smaller organizations, the startups, the kind of independent groups and businesses tend to, like you said, they want to build some things themselves. Maybe they think their situation's unique, and then some of the larger organizations or the kind of the broader use cases tend to be, say, hey, look, let's take advantage of letting other engineering having built it for us, and we'll just build on top of that. And like you said, get going fast, get your projects out there, iterate, and so forth. So let me ask one last question. We'll kind of wrap it up here. Talking about somebody deploying NATS. I mean, NATS obviously, huge scalability capabilities, high performance. What's the typical type of deployment environment? Does it tend to work better in sort of private data centers, private clouds because of the performance elements of it, or how well does it work in private environments where you're sharing resources, or you might be dealing with bandwidth delays and geographic dispersity and things like that?
Well, good question. Again, Apcera is a cloud platform company, and one of the things that we sort of stake our reputation on is. And or our marketing on, quite frankly, is that we're kind of a multi-cloud sort of platform, and I think that extends as well to NATS. It has to, of course, because NATS is such a fundamental component of the system. And so the answer to your question is, we think it performs equally well in private environments as well as in private or public clouds. It really is designed to be that way because, again, limitations that we have experienced in systems that we've built before. We've got quite a few very experienced people here at Apcera in terms of messaging, starting with Derek and others as well, including myself. We've learned a lot of lessons along the way. There are a number of things you can and can't do when your aim is to be broadly applicable in multiple environments. So simplicity and ease of use are key. I think that we're equally applicable in all those environments. I think there are, as with any messaging system and any deployment infrastructure, there are some sensitivities you need to have in terms of how you deploy the system, and there are going to be some differences really in how you organize your clusters of message brokers or NATS daemons in our case. To achieve scale and throughput that meets your organization's objectives. But still respecting the amount of horsepower and the distribution that you've got, between private, public clouds or just private on-premise infrastructure. So it's not, on the one hand, it's not exactly rocket science, but on the other hand, it is because you need to understand what those performance profiles look like, et cetera. But that being said, there's a good answer for each of those environments. It's just going to be a little bit different, and NATS or any messaging system like NATS, hopefully, will provide easy ways to help you do that.
Excellent. Makes sense. Aaron, I've been sort of hogging the conversation. Anything you want to jump in and kind of final last thoughts?
No, I think we're good. It was certainly very educational because for me, this has been the biggest thing is as we kind of move towards this, cloud native architectures, if you will. Yeah, anytime you're breaking things down into smaller components, how do you scale up the communications in between those components? That's always been a key, and that's been kind of really a big learning area for me going forward. So it's been very informative. Thank you, Larry. So, Larry, let me ask you this. As we kind of close this out, where can everyone kind of find out more about you, about Apcera, about NATS.io, and kind of everything going on in the ecosystem?
So first of all, I'm at McQueary on Twitter. That's McQueary. But more importantly, anything and everything you want to know about NATS, you can find at nats.io. It's an open source website, literally, and its subject matter is also open source. But by all means, all of you that are listening, get on there and submit those PRs with all the little mistakes that I probably made in various places. You can also check us out at apcera.com if you're interested in the Apcera platform, obviously. And that's pretty much it.
Fantastic. All right. Well, thank you, Larry, for your time tonight, and thanks everyone for listening.
Thank you for listening to the Cloudcast. Please visit thecloudcast.net to find more shows, show notes, videos, and everything social media.